Hey guys, Mr. Jansen here, ready to take you through 31 through 40 on the 100 illustrated ways to pass the Earth science Regents. So here we go. Number 31, black objects absorb energy while white objects reflect energy. Once again, that dark color is going to have the ability to heat up very quickly. If you ever think about wearing a dark shirt and how hot it can get, and white objects will reflect the energy, okay? And as illustrated here, there's a lot more absorption going on with the dark object and a lot more reflection going on here with the white object. If you do a simple experiment, maybe you did it in class with a black and shiny can, or even here with foil versus blue paper, you can easily measure that the foil is going to reflect more energy and the blue paper will absorb more energy. If you were to see this as a Regents question, it may look something like this. Which type of land surface would most probably reflect the most incoming solar radiation? The keyword being reflect. So you're looking for something that is either white or light colored, and you want something that is smooth, okay? Once again, dark and rough would actually have a lot more surface area, and that would absorb it, but we wanted reflection there, so that's why it's number 1, okay? Number 32, the apparent diameter of objects like the sun and the moon get larger when the object is closer to the Earth. The closer you are to an object, the bigger it's going to appear. Just like, if I come closer to the camera, I'm going to look larger to you, and as I get further from the camera, I'm going to appear smaller to you, okay? So it's the same deal with what's going on in this animation here. The closer you get to the object, the bigger it's going to appear, okay? If this was going to appear as a Regents question, it may look something like this, okay? Diagram below represents 2 photographs of the moon A and B taken at full moon, several months apart. The photographs were taken using the same magnification. Each photo was cut in half and the halves placed next to each other. So, what the question's asking you, okay, is what most likely caused the difference in the apparent size of the moon, even though we're talking about the same moon, okay? And once again, we're talking about how the size will change due to how close or far you are, okay? Or choice D. Okay, number 33. Vertical rays overhead can only occur between 23.5 degrees north and 23.5 degrees south latitude. Those are the tropics. So the only place you can have the sun directly over your head is in between the Tropic of Cancer and the Tropic of Capricorn. Okay, this illustration here is indicating the December solstice, and at that point, at 23.5 degrees, the sun has perpendicular rays, so it's going to appear directly overhead. So you're going to get the most intense incoming solar radiation at point A. Point B is the equator, and there's going to be a slight angle to the incoming solar radiation, as indicated right here. And then point C, up by 30 degrees north latitude, it's either going to be a lower angle, so it's going to be a lot colder in the northern hemisphere on December 21st. Okay. If this were going to appear as a Regents question, it may appear something like this. On December 21st, which latitude would an observer have the sun directly overhead? So you need to know your major stats for the 4 major seasons. And on December 21st, the 23.5 degrees south of the Tropic of Capricorn will have the sun directly overhead. Okay, number 34. Being familiar with this chart, this is that seasonal chart I've been mentioning again and again. Here's your 4 major dates, okay? Here's where the sun is directly overhead, okay, on each of the 4 major dates. Here's where the sun rises and where the sun sets. Here's the altitude of the noontime sun, okay? This looks like for New York State, okay? And this is the length of daylight, okay, for each of these, all right? So this is something you almost have to have memorized walking into the Earth Science Regents exam, okay? A Regents question associated with this is how many times will the sun's perpendicular rays cross the Earth's equator between March 1st of one year and March 1st of the next year? That's a tough question. Okay, so whenever you get a chance, you want to make you can draw all over your Regents and make a mess of it. So let's make a little sun and an Earth. And I'm not going to worry about, the tilt and stuff right now. I'm just worried about where the sun's direct rays are. So on March 1st, the sun's rays are probably going to be right about here-ish. Then on March 21st, the spring equinox is going to hit the equator. Then here's the most direct rays in April. And the most direct rays in June. June 21st is going to be like the Tropic of Cancer, okay? Then you're going to have it in, obviously July, and then August, and then September 23rd, it hits it again, so now I'm up to 2 times. Then you have October, November, then it's going to hit the Tropic of Capricorn, okay, December 21st. then January, February, March 1st. March 1st doesn't make it back to the equator. So it basically crossed over 2 times, okay? So obviously we want, choice 2 over here. It crossed 2 times, okay, or right here, okay? Very good. Okay, number 35. The Coriolis effect, okay? So winds curve to the right in the northern hemisphere and to the left in the southern hemisphere due to the Earth's rotation. We call this the Coriolis effect. So anytime you have these curved arrows, okay, you're deflecting particles to the right in the northern hemisphere and kind of to the left in the southern hemisphere, okay? This is indicated by the planetary winds chart in the reference tables. You can see those curved arrows. So anytime you see curved arrows, you got to think of the Coriolis effect. But what's causing that, okay? It's the spin of the Earth, okay? The fact that the Earth is spinning is causing all these arrows to curve, okay? Regents question, the planetary winds in the northern hemisphere generally curve to the right due to Earth's what? Okay, Earth's spin on the axis, or choice 2. Okay, number 36, energy moves from source to sink or high to low. All right, that's pretty straightforward, okay? This is how winds form. Basically, you have air molecules that are kind of going from where they're all clustered together to a space that's a little bit more open. We call the area of high energy the source and the area of low energy the sink, okay? So energy always travels from high to low. A Regents question, it may appear something like this. Which statement best describes the relationship between a sink and a source if the samples are placed in contact with another? So you have all these different samples here, and if you were to have them to touch, which would be the source, which would be the sink? Well, I can tell you right now by looking at it, dry air has the highest temperature, so that's going to be your source, and then a lower temperature will be the sink. So of your 4 choices there, it seems like choice C, the dry air will be the heat source for the water. Okay. Very good. Okay, 37. Air moves clockwise and outward around a high. So once again, I think of the HOC, H-O-C, high outward clockwise. Maybe that helps out, but it goes outward out of a high. Okay. One of the few things in our science that is clockwise. Okay. The surface winds in a typical northern hemisphere high pressure system are generally moving what? Once again, out of a high and clockwise. Must be memorized, okay? Or choice 3. Okay. Number 38. Air moves counterclockwise and inward around a low. So, maybe lick helps you remember. L-I-C-C, 2 C's. Low, inward, counterclockwise. Once again, have to have that memorized, all right? And what we're looking at here is which map view best represents the pattern of isobar values and the pattern of wind flow shown by the arrows at the Earth's surface surrounding a northern hemisphere low pressure center. So pointing towards the L and going counterclockwise. So which of the 4 choices pointing towards the L and going counterclockwise? Choice 1. Okay, just like that. All right, very good. 39. Good absorbers of radiation are good radiators. So if it heats up quickly, it's going to cool down quickly. Okay, they're doing soil and water in here. Water is has a high specific heat, so it's going to take a long time to heat up, and then it's going to take a long time to cool down. Soil, on the other hand, has a low specific heat, and it's that dark in color, and it's going to heat up very quickly, and it's going to cool down very quickly. Here's your reference tables for the specific heat of common materials listed right here. Basically, you want to be aware that it's here, especially when they ask you to put in order the materials from lowest specific heat to highest specific heat or anything like that. Your Regents question may appear something like this. An object that is a good radiator of electromagnetic waves is also a good, well, that's kind of what we said, it's also a good absorber, okay, or choice 4, or D, okay? The hottest part of the year is in July in the northern hemisphere. Okay, once again, the June solstice, that's when you have the most daylight hours. So someone might think that might be the hottest day of the year. Not necessarily, okay? That's this temperature lag thing that we talk about. In other words, the Earth is still absorbing more energy than it's letting go, okay? So it's actually going to be hotter a little bit later after the solstice, so in late July. Just like the coldest day of the year is not the December solstice, okay? The coldest day of the year will come in late January, while the December solstice, the shortest day of the year, is December 21st, okay? That's that temperature lag. Once again, it's kind of letting out more energy than it's taking in, okay? Regents question may appear something like this. What is the primary reason for New York State? What is the primary reason New York State is warmer in July than in February? Okay, so once again, we're talking about a a question of the insolation, okay, being in New York being greater in July. Okay, once again, it's taking in more energy. Okay, okay. So that's 31 through 40 on the 100 illustrated ways to pass the Regents. Stay tuned for our next video.